Hi everyone. In the next few minutes I'd like to discuss two trends that are happening or will be happening in the near future in the access of mobile networks and their effect on the requirements from last mile backhaul. We at Siklu believe that millimeter waves, and specifically the 70-80 GHz E-band and the 60 GHz band, can provide an answer to these requirements and challenges and provide an affordable and scalable migration path to a macro and micro multi-layered network. The first trend I'd like to talk about is the transition from base stations being large cabinets or shelters to becoming zero footprint, all outdoor base stations. With the base stations being large, site acquisition is both very hard and expensive, and it takes a long time to complete. In addition, once the site is available, transporting and installing the base station is hard due to the bulkiness and weight of the equipment. The large macro cells are not very environmentally friendly, with very high power consumption, noisy, and of course very visible. And the bottom line is that it's very expensive, both from a CapEx and an OpEx point of view. So the transition to zero footprint, all outdoor base stations is very natural, making site acquisition and installation much easier, being more environmentally friendly in terms of power consumption and visibility, and all in all, providing a lower cost. The need to increase capacity is resulting in the deployment of more and more cells, particularly in urban deployments where site acquisition is even harder and visibility is an even more important factor. And of course, the total cost of ownership needs to be as low as possible. So this transition is a must. The second trend we're seeing is a transition to a multi-layered access network, where macro cells will provide the capacity and the coverage, and the micro cells will provide the high-capacity hotspot coverage. We will eventually reach the capacity limits that a single layered network can provide, so it's just a matter of time until multi-layered access networks will become common. And as we see when it comes to data usage, this will probably come sooner than we anticipate. We believe that millimeter waves, specifically the 70-80 GHz E-band and the 60 GHz band, can step up to these challenges. The 70-80 GHz E-band is optimized for providing last-mile backhaul to the zero-footprint macro cells, and the 60 GHz band is optimized for the microcell backhaul that we may also call the zero-mile backhaul. Why is this so? These bands are optimized for short-range, high-capacity links with a large allocated spectrum allowing gigabit per second and above capacities. It provides an answer to the spectrum bottleneck and the congestion of lower frequencies, as these bands are still virgin on one hand and have a high reuse factor. Systems that are small, all outdoor, zero footprint, and have low power consumptions are achievable and are already available. And finally, these systems may be low cost and even very low cost. So let's take a closer look at the requirements of the zero footprint macro cells and the implications for the backhaul requirements. The zero footprint macro cell is usually installed on rooftops, either pole or wall mounted. Site acquisition should be relatively fast and simple. It's relatively small and of course lower cost than the old sheltered base stations. The implications of this on the backhaul requirements are that the backhaul also needs to be all outdoor with a low profile in terms of visibility. The installation should be quick and easy. It should be scalable both in terms of capacity and capabilities to support not only current requirements, but also the future requirements and evolving topologies. It has to include carrier networking capabilities so that we don't need an additional indoor demarcation device and we can daisy chain or deploy rings on the roof or pole without going indoors. Power consumption should be low. Frequency planning and acquisition has to be fast and cheap to provide greater flexibility. And of course, let's not forget the low cost. As the cost of the zero footprint base station is reduced, the cost of the backhaul has to be reduced by the same factor. We believe that the 70-80 GHz band provides an optimized answer to the requirements we just mentioned. Everything starts with the spectrum characteristics that allow us to design and manufacture an all-silicon integrated solution in terms of both the RF and the baseband. And going to this deep silicon integration allows us to reduce the cost of the equipment to get it to very small form factor with very low power consumption and high reliability. In addition, antennas operating at the E-band are small with a high gain, allowing to provide the required reach sufficient in the last mile. The large allocated spectrum allows us to achieve high-capacity gigabit systems. In addition, as I said earlier, the spectrum is still virgin, and together with the highly directional pencil beams, allows easy and fast frequency planning, and also high reuse of the spectrum. And lastly, the licensing schemes allow us to get a frequency very fast and significantly cheaper compared to the lower bands. Now let's take a closer look at the requirements of microcells and the implications for backhaul. The microcells will be installed on the street level and even indoor. Its size is going to be very small and invisible to the eye. Site acquisition and installation should be very fast, and of course it'll be significantly lower cost than even the zero footprint base stations. The implications on the backhaul requirements are that the backhaul also needs to be invisible and seamlessly integrated with a microcell. We're talking about zero cabling. The installation has to be quick and easy. Once again, it should be scalable both in terms of the capacity and the capability to support current requirements, future requirements, and evolving topologies. It also has to include carrier networking capabilities so that you don't need an additional indoor demarcation device and you can daisy chain or ring on the wall or pole. Power consumption has to be extremely low. Frequency planning and acquisition has to be both fast and cheaper to provide greater flexibility. And of course, let's not forget that it has to be very low cost. We believe that the 60 GHz band provides an optimized answer to the requirements we just talked about. Again, we start with the fact that the spectrum characteristics allow us to do an all-silicon integrated design. Going into this deep silicon integration reduces the cost of the equipment. It makes it smaller, under 3 liters for the whole system, including antenna, RF baseband interfaces. We're talking about even lower power consumption and high reliability. And as the 60 GHz band is unlicensed in many countries, very small antennas may be developed, allowing to reach the required distances. Of course, doing all of this allows us to integrate between the microcell and the backhaul in one small form factor. Here too, the large allocated spectrum allows us to achieve high capacity systems. In addition, as I said earlier, the spectrum is still virgin, and together with a high atmospheric attenuation, easy and fast frequency planning and high reuse of the spectrum is possible with a low risk of interference. So, to conclude, mobile networks are evolving to a multi-layered access network to cope with the exploding demand for data-intensive services. Backhaul is one of the key challenges operators are facing and they need to overcome in their evolution to the multi-layered access mobile network. Millimeter wave backhaul will play an important role in answering the backhaul challenge. The 70-80 GHz E-band is optimized for last mile zero footprint macrocell backhaul, while the 60 GHz spectrum is optimized for microcell and picocell backhaul. Millimeter wave backhaul solutions provide dominant advantages in total cost per ownership, scalability, form factor and size, and environmentally friendliness. Thank you for your time, and if you'd like to learn more, you can go to www.siklu.com.